Interacting with REST APIs and Python. There's a huge amount of data available on the web. Many web services, such as YouTube and GitHub, make their data accessible to third-party applications through an application programming interface known as an API. One of the most popular ways to build APIs is the REST architecture style. Python provides some great tools not only to get data from REST APIs, but also to build your own Python REST APIs. In this course, you'll learn what REST architecture is, how REST APIs provide access to web data, how to consume data from REST APIs using the request library, what steps to take to design a REST API, and how to use some popular Python tools to build a REST API. By using Python and REST APIs, you can retrieve, parse, update, and manipulate the data provided by any web service you're interested in. Any code that you see running in the REPL will be using the bpython interpreter. This is a replacement Python interpreter that offers a number of enhancements, including code highlighting and suggestions, but any code you see running on screen will work in the Python REPL, which is typically accessed by typing Python or Python 3 at your terminal or command line prompt. Don't forget to download the course materials, as they include full versions of all the API applications that you'll create in the course, as well as supporting files which will make your learning experience easier. And when you finish the course, take the interactive quiz which will help you track your learning progress. So now you know what's going to be covered, let's get started. REST APIs and web services. Before getting into the details of APIs and web services, it's time to take a look at what REST means and its architecture. REST stands for Representational State Transfer and is a software architecture style that defines a pattern for client and server communications over a network. REST provides a set of constraints for software architecture to promote performance, scalability, simplicity, and reliability in the system. REST defines the following architectural constraints. Stateless. The server won't maintain any state between requests from the client. Client-server. The client and server must be decoupled from each other, allowing each to develop independently. Cacheable. The data retrieved from the server should be cacheable either by the client or by the server. Uniform interface. The server will provide a uniform interface for accessing resources without defining their representation. Layered system. The client may access the resources on the server indirectly through other layers such as a proxy or load balancer. Code on demand. The server may transfer code to the client that it can run, such as JavaScript for a single-page application. Note, REST is not a specification, but a set of guidelines on how to architect a network-connected software system. A REST web service is any web service that adheres to REST architecture constraints. These web services expose their data to the outside world through an API. REST APIs provide access to web service data through public web URLs. For example, on screen is one of the URLs for GitHub's REST API. This URL allows you to access information about a specific GitHub user. You access data from a REST API by sending an HTTP request to a specific URL and processing the response. You can see a typical response on screen. Its appearance will depend on the browser you're using, and in this case you're seeing Firefox's interpretation of the data that's received. REST APIs listen for HTTP methods like GET, POST, and DELETE to know which operations to perform on the web service's resources. A resource is any data available in the web service that can be accessed and manipulated with HTTP requests to the REST API. The HTTP method tells the API which action to perform on the resource. While there are many HTTP methods, the 5 methods seen on screen are the most commonly used with REST APIs. A REST API client application can use these 5 HTTP methods to manage the state of resources in the web service. Once a REST API receives and processes an HTTP request, it will return an HTTP response. Included in this response is an HTTP status code. This code provides information about the results of the request. An application sending results to the API can check the status code and perform actions based on the result. These actions could include handling errors or displaying a success message to the user. Status codes are numbered based on the category of the result, as you can see in the table on screen. In more detail, on screen you can see a list of the most common status codes returned by REST APIs. These codes represent only a small subset of the available HTTP status codes. Status codes come in handy when working with REST APIs, as you'll often need to perform different logic based on the results of the request. A REST API exposes a set of public URLs that the client applications use to access the resources of a web service. These URLs, in the context of an API, are called endpoints. To clarify this, take a look at the table on screen. Here you'll see API endpoints for a hypothetical CRM system. These endpoints are for a customer resource that represents potential customers in the system. Each of the endpoints seen here performs a different action based on the HTTP method. Note that the base URL for the endpoints has been omitted for clarity. In reality, you'll need the full URL path to access an API endpoint. The base URL is everything besides customers. You'll note that some endpoints have customer ID at the end. This notation means you need to append a numeric customer ID to the URL to tell the REST API which customer you'd like to work with. The endpoints listed in the table represent only one resource in the system. Production-ready REST APIs often have tens or even hundreds of different endpoints to manage the resources in the web service. So now that you know what REST APIs are, next you'll take a look at how you can consume them with Python. REST and Python, consuming APIs. In the next two parts of the course, you'll see how to consume APIs with Python. To write code that interacts with REST APIs, most Python developers turn to requests to send HTTP requests. This library abstracts away the complexities of making HTTP requests. It's one of the few projects worth treating as if it's part of the standard library. To start using requests, you'll need to install it first. You can use pip to install it, and it's good practice to do this into a virtual environment, so on screen you'll see the commands you'll need to do this on macOS or Linux. And here's what you'd need to do the same on Windows. Note that only the activation line is different. Now that you've got requests installed, you can start sending HTTP requests. GET is one of the most common HTTP methods you'll use when working with REST APIs. This method allows you to retrieve resources from a given API. GET is a read-only operation, so you shouldn't try to use it to modify an existing resource. To test out GET and the other methods in this section, you'll use a service called JSON Placeholder. This free service provides fake API endpoints that send back responses that requests can process. To try this out, start up the REPL and run the command seen on screen to send a GET request to a JSON placeholder endpoint. This code calls request.get to send a GET request to todos 1, which responds with the to-do item with the ID of 1. Then you call the JSON method on the response object to view the data that came back from the API. The response data is formatted as JSON, a key value store similar to a Python dictionary. It's a very popular data format and the de facto interchange format for most REST APIs. Beyond viewing the JSON data from the API, you can also view other things about the response. Here you access response.status code to see the HTTP status code. You can also view the response's HTTP headers with response.headers. This dictionary contains metadata about the response, such as the content type of the response. Post is another common HTTP method. As the name suggests, it allows the client to send a resource to the API to be processed. This method is commonly used in the processing of data sent by forms on web pages, and it allows the creation of new resources on the server. You'll now look at how to use requests to post data to a REST API to create a new resource. You'll use JSON placeholder again, but this time you'll include JSON data in the request. On screen, you can see the data that you'll be sending. This JSON data contains information for a new to-do item. Back in the REPL, run the code seen on screen to create the to-do. First, you create a dictionary containing the data for your to-do. Then you pass this dictionary to the JSON keyword argument of request.post. When you do this, request.post automatically sets the request's HTTP header content type to application JSON. It also serializes to-do into a JSON string, which it appends to the body of the request. If you don't use the JSON keyword argument to supply the JSON data, then you need to set content type accordingly and serialize the JSON manually. Here's an equivalent version to the previous code. In this code, you add a headers dictionary that contains a single header content type set to application JSON. This tells the REST API that you're sending JSON data with the request. You then call request.post, but instead of passing to-do to the JSON argument, you first call json.dumps to-do to serialize it. After it's serialized, you pass it to the data keyword argument. The data argument tells requests what data to include in the request. You also pass the headers dictionary to request.post to set the HTTP headers manually. When you call request.post like this, it has the same effect as the previous code, but gives you more control over the request. Note that json.dumps comes from the JSON package in the standard library. This package provides useful methods for working with JSON in Python, and you can learn more about it in this Real Python video course. Once the API responds, you call response.json to view the JSON. The JSON includes a generated ID for the new to-do. The 201 status code tells you that a new resource was created. Now you've seen what are arguably the most common request types, in the next section of the course, you'll look at three others: put, patch, and delete. Put, patch, and delete. Beyond get and post, requests provide support for all the other HTTP methods you would use with a REST API. Put asks the server to process the resource that is sent to the API, and it allows the creation or updating of a resource. It's most commonly used when updating an existing resource. The code you'll see on screen sends a put request to update an existing to-do with new data. Any data sent with a put request will completely replace the existing values of the to-do. You'll use the same JSON placeholder endpoint you use with get and post, but this time you'll append 10 to the end of the URL. This tells the REST API which to-do you'd like to update. First, you call request.get to view the contents of the existing to-do. Next, you call request.put with new JSON data to replace the existing to-do's values. You can see the new values when you call response.json. Successful put requests will always return 200 instead of 201 because you aren't creating a new resource, but just updating an existing one. Patch is another HTTP method, and it's similar to put. Once more, it requests that the server processes the resource sent to the API, but it allows partial modification of a resource. Here, you'll use request.patch to modify the value of a specific field on an existing to-do. Patch differs from put in that it doesn't completely replace the existing resource. It only modifies the value set in the JSON sent with the request. You'll use the same to-do from the last example to try out request.patch, and here are the current values. Now you can update title with a new value. When you call response.json, you can see that title has been updated to mow lawn. Delete is used when you want to remove a resource using an API. Note that depending on the way the API is created, this may just mean removing access to a resource such as an image or other uploaded file, rather than actually deleting the file from the server. Here's the code to remove a to-do. You call request.delete with an API URL that contains the ID for the to-do you'd like to remove. This sends a delete request to the REST API, which then removes the matching resource. After deleting the resource, the API sends back an empty JSON object indicating that the resource has been deleted. The request library is a great tool for working with REST APIs and an indispensable part of your Python toolkit. In the next section, you'll change gears and consider what it takes to design a REST API. Designing APIs. REST API design is a huge topic with many layers. As with most things in technology, there's a wide range of opinions on the best approach to building APIs. In this section, you'll look at some recommended steps to follow as you build an API. The first step you'll take as you build a REST API is to identify the resources the API will manage. It's common to describe these resources as plural nouns, like customers, events, or transactions. As you identify different resources in your web service, you'll build out a list of nouns that describe the different data users can manage in the API. As you do this, make sure to consider any nested resources. For example, customers may have sales, or events may contain guests. Establishing these resource hierarchies will help when you define API endpoints. Once you've identified the resources in your web service, you'll want to use these to define the API endpoints. Here are some example endpoints for a transactions resource you might find in an API for a payment processing service. These 6 endpoints cover all the operations that you'll need to create, read, update, and delete transactions in the web service. Each resource in your web service would have a similar list of endpoints based on what actions a user can perform with the API. An endpoint shouldn't contain verbs. Instead, you should select the appropriate HTTP methods to convey the endpoint's action. For example, the endpoint seen here contains an unneeded verb. Get is included in the endpoint when it's not needed. The HTTP method get already provides the semantic meaning for the endpoint by indicating the action, so you can remove it from the endpoint. This endpoint contains only a plural noun, and the HTTP method get communicates the action. Now take a look at an example of endpoints for a nested resource. Here you'll see endpoints for guests that are nested under events resources. With these endpoints, you can manage guests for a specific event in the system. This isn't the only way to define an endpoint for nested resources. Some people prefer to use query strings to access a nested resource. A query string allows you to send additional parameters with your HTTP request. In the endpoint seen on screen, you append a query string to get guests for a specific event ID. This endpoint will filter out any guests that don't reference the given event ID. As with many things in API design, you need to decide which method fits your web service best. It's very unlikely that your REST API will stay the same throughout the life of your web service. Resources will change, and you'll need to update your endpoints to reflect these changes. This is where API versioning comes in. API versioning allows you to modify your API without fear of breaking existing integrations. There's a wide range of versioning strategies. Selecting the right option depends on the requirements of your API. On screen are some of the most popular options for API versioning. URI versioning. Each time you modify the web API or change the schema of resources, you add a version number to the URI for each resource. HTTP header versioning. Here you implement a custom header that indicates the version of the resource. Query string versioning. Rather than providing multiple URIs, you can specify the version of the resource by using a parameter within the query string appended to the HTTP request. And media type versioning. When a client application sends an HTTP GET request to a web server, it should stipulate the format of the content that it can handle. Regardless of which strategy you select, versioning your APIs is an important step to ensuring if it can adapt to changing requirements while supporting existing users. Now that you've covered endpoints, in the next section you'll look at some options for formatting data in your REST API and designing success and error responses.